Alrighty, this lab is lab 4.3, comparing the concentrations of saturated solutions. There's two things that make this lab a little bit on the complicated side. First is just procedurally, it takes some time to get through all the stuff we've got to do. The second thing is the math. This is kind of like, it reminds me a little bit of when we did the density of a gas. Because we couldn't measure the gas directly, so we had to do all these other things in this roundabout, indirect way to get to the numbers. So that's kind of like this lab today. So when we get to the point where I'm showing you the data, you're going to see we're taking all these different measurements really just to get to two numbers, one main number at the end, but two numbers that we'll use in a calculation at the end. So let's look at the title of the lab, comparing the concentrations of saturated solutions. So there's really two key vocabulary terms there. The first one is concentration, and the second one is saturated solution. So let's start with saturated solution. In yesterday's lab 4.1, the main point was to create a saturated solution and for you to see what that kind of looks like. So what we've done today is we've created two saturated solutions using two different substances. So this one is substance A, if you can see it on there. There's the A, substance A, and you know it's saturated. I don't know if you can see it very well. I'll try to hold this up behind it for you to see it. It definitely makes a difference if you can see what I'm talking about. Okay, well that's white too, and that doesn't help. Well, okay, you might not be able to see it. I tried to turn off the light to get rid of the glare, but oh, that's better against the black table. Okay, let's do that. You can see at the bottom here, there's a lot of solid that's left undissolved. So what we did was I probably used that's probably about 20 cubic centimeters of water, and probably for substance A, it's probably about 10 grams of substance A. And I shook it up for quite a while. I did this already just to kind of make the time go a little faster on the video. I shook it up quite a bit, and so I know that this is saturated because I can see that there's undissolved solid left in the bottom. So you guys can see that down here. So the first part of this is to create saturated solutions. And again, the only way we know it's saturated is when we can physically see that there's leftover solid in the bottom of the test tube that hasn't dissolved. So that one is substance A, and this one is substance B. Probably about the same numbers, probably about, no, you know what, there's probably a lot more solid in here. Maybe about 20 to 25 cubic centimeters of water, probably about, 20 to 25 grams of substance is what I had to put in here to get it to be saturated. So again, same thing. I just added a bunch of solid and shook it up and mixed it to the point where no more will dissolve. So I'm starting with two saturated solutions, two different saturated solutions. For the purpose of the lab, we're just going to call them A and B, just for simplicity's sake, because it doesn't really matter what the substances are. Okay, so that's the saturated solution part. That part's done. Now what I want to know is what's the concentration of each of these saturated solutions. So now we need to know what concentration is. So I already kind of prepared this ahead of time in terms of trying to look at the numbers. There's a lot on here. Right now we're just going to look at this number right here where it says mass of dissolved solid per 100 cubic centimeters. So when we look at concentration, concentration basically tells us the mass of the dissolved solid, so how much solid is dissolved in a certain amount of liquid. That's what concentration is. And if you need to kind of refresh on that a little bit, you can go back and look at 4.2. You can read through that. I also did a pencast on 4.2, which you can listen to. So again, concentration is how much solid, the mass of the dissolved solid, in a certain amount of liquid. The main thing with concentration is this word right here, dissolved. I put probably, I don't know, 10 or 15 grams of substance in here, but not all of it dissolved. So the fact that I put 10 or 15 grams in there means nothing. I want to know how much actually dissolves in the solution. Because if it doesn't dissolve, it's not actually part of the solution. And remember, we're trying to find the concentration of the solution. So if it doesn't dissolve, then it's not part of the solution. So we're trying to figure out how much actually dissolves. Okay, so that's what we're trying to get at here. Now, that's why this lab is difficult, because I have no idea how much dissolved. I know that I put a bunch in there and I mixed it up, and I know a lot of it dissolved. I know there's some left over. So we're going to figure out how much actually dissolves, how much of this substance actually dissolved into the water. All right, and as we go, I'm going to kind of explain the process in steps as we go. The first thing we're going to do is to take a sample of the solution. Now, I don't need to use all of the total amount of solution. I'm just going to take a sample of it and analyze just a sample. And the reason I can do that is because what we learned in lab 4.1 is that when a solid dissolves in a liquid, it will evenly distribute itself throughout the entire solution. So if you think back to our lab from 4.1, the color of the solution was uniform all the way throughout, which means that blue solid dissolved evenly throughout the whole solution. So we're going to take that concept and apply it here. Even though this is a white substance, and when it dissolves we can't see the color, the same principle applies. The solid material that dissolved in the liquid distributes itself evenly throughout the entire liquid. So all I have to do is take a small portion of this solution in order to analyze it. And then from there it's just a proportion. If I figure out how much solid dissolves in one portion of this, then I can figure out how much dissolves in 100 cubic centimeters, which is what the concentration is. So all of that to say, we're just going to use a small portion of this. We don't have to use all of it because the solid distributes itself evenly throughout. So a small portion will give us exactly what we need. So we're going to start with a small portion of it. So what I want to do first is figure out, I'm going to pour a little bit of solution into a container. And I want to figure out how much sample am I going to start with. Okay, so I want to figure out the mass of a sample. Now, because it's a liquid, and I want to get the mass, I obviously have to have some container to put it in. So I'm going to mass the container first. So let's do that, and we'll write it down. And we'll start with substance A. So the massing dish that we're going to use for substance A is 26.59. 26.59 grams. Okay, that's important because we're going to use that number. There's a glare. We're going to use that number to figure out later this number up here, how much solution we have. Okay, so I know how much the dish is. Now I'm going to take solution A and I'm going to pour it just a little bit. Remember, I just need a sample. I don't need all of it. So I'm going to pour a little bit in here. And I'm going to mass the total, the dish and the solution together, which is 33.44. So the dish plus the solution together is 33.44 grams. Okay, now I'm going to grab my calculator and figure out how much solution I'm starting with. So, if you look down here, if I know how much the dish is, and I know the dish plus the solution, I can subtract this number from this number to figure out how much is just the solution. So that's the number I want to start with up here. So I'm going to do 33.44 minus 26.59. So I'm starting with 6.85 grams of solution. So that's the first number. Now, it's important to note, and I'm going to write this down here, the solution, and you guys know this, but it's important to keep it in mind. The solution is made up of two parts. It's made up of solid, and to be exact, dissolved solid, plus the liquid. Okay, so let's look at this right here. The solution is made up of two parts. Dissolved solid plus liquid. So I, right now, know the total amount. I know exactly how much solution I'm starting with, 6.85 grams. Okay? All right. Now here's what we're going to do. I somehow need to separate the liquid from the solid. And I don't know, you can't see it probably. I'll just show you again from here. You can see it's a clear liquid. Okay? It looks pretty much just like water. I want to be able to separate out the liquid from the solid. right? So if we look back over here, if I know how much solution I have, I want to then separate these two, because if we go back to here, this is what I'm trying to figure out in the end. How much dissolved solid is there, and how much can dissolve into 100 cubic centimeters of water. So I want to break this down into its two parts. So I know I'm starting with 6.85. What I'm going to do is now evaporate the liquid. It's water, so we're going to boil it until it boils off. That's how I'm going to separate these two things. Okay, so I'm going to put this on the hot plate right here, and I'm going to turn up the heat a little bit to where it's a decent temperature. And what I'm going to do, let's see, I'll put A on that side. What I'm going to do is let all of the water boil off, so that I'm essentially taking the water out, and I'm going to have the solid left over. So right now, whatever solid is actually dissolved in that liquid, we can't see it because it's dissolved in the liquid. So as soon as we get rid of all the liquid, we'll be able to see exactly how much solid is in there. And then we can mask that and kind of go from there. Okay, so that's liquid A. Let's go ahead and do liquid B, because we want to be able to compare them. So we're going to take the mass of the massing dish for the one we're going to use for liquid B, or solution B, I should say. That's 26.87. So the dish is 26.87 grams. Okay, so here we go. Substance B, the dish right here is 26.87. Okay. Now I'm going to pour some of my substance B. Let's double check, that's B. I'm going to pour some of that, over here, into the massing dish. And take the mass of both the dish and the substance together. Now I can move this out of the way. Okay. All right, so together, the dish plus the solution together is 36.18. And again, I'm going to subtract those, because the dish plus the solution minus the dish tells me how much solution I have. So 36.18 minus 26.87 means I have 9.31 grams of solution. So here's what we're starting with substance B. So here's the mass of the dish. Then I poured in some of the solution. And then to figure out how much solution I have, I just subtract those two, right? That's dish plus solution, subtract out the mass of the dish. And I'm starting with 9.31 grams of solution. Again, just like with substance A, that number is made up of two parts. It's made up of dissolved solid, and it's made up of liquid. What we're going to do, again, is boil off all the water so that we can figure out how much of this number, or how much of the solution, is made up of the dissolved solid, right? Because that's really one of the key numbers here when we try to find the concentration. So I have my solution B in the evaporating dish. I'm going to put it on the hot plate and let it boil. This is the part of the lab that takes a while. So for those of you watching at this point, you can probably just fast forward until I come back and remass it again at the end, because I'm just going to let it boil. I'm going to walk away, I'm going to let it boil, and then I'll come back in a little while, and we'll kind of, once it's done evaporating, and we'll go through the rest of the data. So feel free at this point to fast forward. quite done yet. Alright, we're getting there. The reason we have to be really careful with this part is because if it's not totally dry, if there's still water in there, then when we mass it to figure out the mass of the dissolved solid, it's going to be heavier than what it should be because there will be water in there as well. So we want to make sure it's totally dry so that what we're massing is just the solid alone so that it doesn't throw our numbers off. This one always takes a little bit longer. That's okay. I think B is ready, but I'm going to be smart and just wait a couple more minutes just to be on the safe side. we're going to start with B. Hopefully you can, if you had to fast forward, you can watch. This is the part you need to watch again to get the numbers. Okay. Substance B appears to be drier than substance A. Appears to be totally dry, where substance A looks, it's possible that it needs to dry out a little bit more, so we'll go ahead and work with substance B first, and then we'll come back. Alright, so, this is the part that might be hard to see. Let me get love. I really want you guys to be able to see what this looks like when we're done. I have no idea if this is going to allow us to see or not. Let's see. What you should be able to see, and I don't know if it's coming across that well in the video, is that there's like a white powdery, like crystal-like substance almost in the bottom of the dish. And it's hard to see on the video. In person, it's a lot easier to see. What you should notice, though, is that there's definitely something in the bottom of that evaporating dish. So if you think back to what we started with, we started with this liquid that looks clear, looks just like water. I took a portion of that clear liquid, which is really a solution, poured it into the dish, and got rid of all the water. It's just really fascinating that all of this is left over once we get rid of the clear liquid, of the water, because it doesn't look like all that stuff is dissolved in there when you first look at it. I don't know, so I always find that fascinating. So it's not easy to see from where you're at, but there's definitely white powdery substance left over. Okay, so we want to figure out how much that is. That, because this is going to be the mass of our dissolved solid. So let's think about it for a second. We poured the solution in here. The solution is made up of water plus dissolved solid. We got rid of the water. The dissolved solid is left over. Now we're going to mass the dissolved solid, so that we can figure out our concentration. So let's put this back on here. This is substance B. Okay, the mass of the dish plus the solid is 31.80. So here we go, down here. The dish plus the solid is 31.80. So now what we're going to do is take this number, subtract the mass of the dish, and then we know how much solid we had. We know how much solid had been dissolved in that solution. So let's see, 31.80 minus 26.87 is 4.93. 4.93 grams. Okay, so now let's look at this. So we started with 9.31 grams of the solution. Remember, the solution is made up of dissolved solid plus liquid. Now we know how much was just the solid. So out of 9.31 grams, 4.93 of it was dissolved solid, which means the rest of it has to be the liquid, because the solution is only made up of two parts, solid and liquid. We know how much solid there is, we can subtract to figure out the mass of the liquid. So now we do 9.31 minus 4.93. That tells us that the mass of the liquid is 4.38 grams. Okay, here's another one of those like indirect types of measurement calculation things that we have to know. Remember, our liquid that we're using is water. This tells us the mass of the water. When we do concentration, we need to know the volume, not the mass. So we're good here because we need to know the mass of the dissolved solids, and this is good. We're fine with this one. What we need to figure out now is if I have 4.38 grams of water, how much volume is that? So here's the easy way to do this. And I'm going to make a little sidebar over here. We know the density of water is 1.0 grams per cubic centimeter. Okay? And I'm going to show you two easy ways to do this. You guys know, if you're in my class, you know this little circle method, right? The density of water is 1. So if I know the mass of water up here, and I know the density, I can figure out the volume. And if I cover up volume, what's left over is my formula, which would be mass divided by density. So mass, 4.38, divided by 1, which I don't even have to put in the calculator. I can do that in my head. 4.38 divided by 1 is just 4.38. So going forward, it's important that you guys recognize that when we're dealing with water, and this only works with water because water is the only substance whose density is 1. However much mass I have of water, the volume will be the exact same number, just a different unit, that's all. So for example, if I have 5 grams of water, that 5 grams has a volume of 5 cubic centimeters. If I have 10 grams of water, that water has a volume of 10 cubic centimeters. So whatever mass I have, I also have the same volume. Only when we're talking about water, that only works with water. Okay, but here's the good news. Now we know the volume of the liquid. And remember, concentration is mass of dissolved solid divided by volume of liquid times 100. Remember, that unit of measure is very important. For those of you that aren't here, I'm going to talk more about that on the pencast. So make sure to look for that later on as well. So we're going to do 4.93 divided by 4.38 times 100. All right, so this is a little bit high. I was hoping that the numbers would be better because we had time to make sure it got really dry. But it's a little bit on the high side, but that's okay. What we found with these numbers is that the concentration of saturated solution B is 112 grams per 100 cubic centimeters. So let me say this in plain English. What this means is for substance B, no more than 112 grams can dissolve in 100 cubic centimeters. The maximum amount of substance B that can dissolve into 100 cubic centimeters of water is 112 grams. This is called the solubility of a substance. Scientifically speaking, if you look at the end of this lab, it tells you solubility is the concentration, that's this, of a saturated solution. So we made a saturated solution and we found its concentration. So now we know the solubility of substance B. Again, to put it in plain English, solubility simply means the maximum amount of substance that can dissolve into 100 cubic centimeters of solution. Solubility is a characteristic property. It's characteristic to the pair meaning the solid and liquid together, okay? So substance B is very soluble in water. That doesn't mean it's going to be very soluble in rubbing alcohol or in some other liquid. So when I say it's a characteristic property to the pair, I'm talking about it's going to be specific to the solid and what liquid that solid is dissolving into, okay? So substance B is very soluble in water because 112 grams will dissolve in 100 cubic centimeters. Now it's probably important to note the actual solubility of substance B is 96 grams per 100 cubic centimeters. Okay, this is the actual solubility. So my number's a little bit high on the high side, probably because I didn't dry it out enough. It probably needed to probably heat a little bit longer to evaporate a little bit more of the water. That number's probably high because it probably still has some water in there. So this is what the number should be. It should be 96 grams per 100 cubic centimeters, which again is still very highly soluble. Okay, let's go through and do A really quick. The discussion for substance A doesn't need to be quite as long because I gave you pretty much the gist of it with that one. So we're going to find the mass of the dish plus the remaining solid. Substance A also has a lot of white solid left over in the dish once all the liquid was removed. Okay, so the mass of the dish plus the solid together is 29.02 grams. And if I subtract out the mass of the dish, that's 29.02 minus 26.59. So the mass of our solid is 2.43 grams. Let me show you how I did that really quick. I got the mass of the dish and the solid at the end once all the water was gone. I subtracted the mass of the dish, and that gives me the mass of the solid. Now, the solution is 6.85. 2.43 of that is the solid, so I can subtract those two to figure out the mass of the liquid. So 6.85 minus 2.43 equals 4.42. Okay, Now that tells me the mass of the water that was in the solution. And remember, because it's water and water has a density of 1, whatever the mass is, so is the volume. So the volume of that water is also 4.42, except we say 4.42 cubic centimeters instead of grams, because cubic centimeters is the unit that we use for volume. So now I know the mass of my dissolved solid, and I know the volume of the liquid. These are the two numbers that we use to figure out the concentration. And then we multiply it times 100. That's one of the important parts. So 2.43 divided by 4.42. Okay, that's a little bit on the high side as well. But that's okay. It still shows you the entire process and gets us where we need to be. So when I do 2.43 divided by 4.42, I get 0.549 and then a whole bunch of other numbers. And then I multiply that times 100. And yes, I do want to use significant digits. So we've got 3 here and we've got 3 here. So my answer should have 3. So what this tells me is that, probably should have done that with the other one also. That's okay. So that tells me that about, actually we'll round it. We're gonna go about 55 grams per 100 cubic centimeters. Okay, so let's look at what this means again. This is the solubility of substance A. Solubility is the concentration of a saturated solution. So, at the beginning, we created a saturated solution with substance A and water. We know it was saturated because we know that there was no more solid that could possibly dissolve in the liquid. We can look at it again if we need to. Then we took a sample of that liquid and we determined its concentration. So, solubility is the concentration of a saturated solution. And again, in plain English, what this means is that for substance A, 55 grams will dissolve into 100 cubic centimeters of water. That's the maximum amount of substance A that can dissolve into 100 cubic centimeters of water. If I were to put 56 in the test tube, then there would be 1 gram that would not dissolve and the rest would. That's theoretically what this means. The maximum amount of substance that can dissolve into 100 cubic centimeters of water. Now, as I mentioned before, this number is also a little bit high. What it should be for substance A is 34 grams per 100. This is the actual solubility, this one right here. Okay, so my numbers are a little bit off, again, probably because I didn't get it dry enough. So that number's a little bit high, probably because there's still some water in there. This is what it should be. So for substance A, 34 grams will dissolve per 100 cubic centimeters. That is the actual solubility of substance A. Okay? And that is a characteristic property. So you can tell if you compare the two for substance A and substance B. Substance B will dissolve 96 grams per 100 cubic centimeters, whereas substance A will only dissolve 34 grams per 100 cubic centimeters. Substance B is a lot more soluble than substance A. A lot more of substance B will dissolve in 100 cubic centimeters of water than substance A. So again, solubility is a characteristic property that's going to be specific to the solution, which would be the solid and the liquid together. And it can help us to distinguish between substances. Okay, for my kids, I am going to have a separate pen cast as well that kind of goes through the math if you need that. But that should give you the gist of what we did in Lab 4.3.